All right, so let's look at example 2 in our textbook here as we evaluate triple integrals. This one's going to use a tetrahedron. So we're going to look at the volume of the tetrahedron with vertices at the origin, A being at 1, 1, and 0, B being 0, 1, 0, and C being 0, 1, 1. So I'm going to start by drawing this. Let's see if I can get a grid system here. So here will be my origin. And I'll move my x-axis out this way. And my y-axis out this way. And my z-axis straight up. So I'll make these halves. So let's get our points together. So this will be the point at the origin, O, the vertice at the origin, 0, 0, 0. And then we want a point at A is 1, so let's make each of these a quarter. So I'm going to go 1 in the x direction. So 1, 2, 3, 4, and 1 in the y direction, 4. So that's A at 1, 1, 0. And then B is 0, 1, 0. So 1, 2, 3, 4. Here's B. 0, 1, 0. And then in C is 0, 1, and then an up 1. So let's see, 1, 2, 3, 4, 1, 2, 3, 4, up here. So that is C, oops, that's B, at 0, 1, 0, or 0, 1, 1. So 1 in the height in Z, 1, 2, 3, 4. Oh, I got it a little higher than I needed to. Sorry, there's 4. All right, 1, 2, 3, 4. Yep, we're over 4 there. All right, so this is our figure. So we have our drawing here, the tetrahedron. We'll connect our vertices. And we have the shape that we're looking at here. And so we want to figure out the volume of this. I'm going to turn off my grids now, and we have the shape that we need to look at. So what we start with is we're going to take some point M. Right? We're going to have, if this is my x direction, my y direction, and my z direction, then we're going to want to have some point M in the xy plane in the shadow. And we're going to ask ourselves, running perpendicular here from the shadow, that'll be our ray M coming out. There's M. And so we need to ask ourselves, at what point does it enter and at what point does it leave. Why did I write a B? I wanted to write M. This is our array M. And so that'll be our integration in Z. And then we're going to want to look at some L that's working its way parallel to the x-axis. So we'll have L come through M. Oops, wrong. Use my tool here. Let's have L ride through here. And there's some ray L. And so this will help us figure out our points of integration that we need to use. So what we want to be able to do then is calculate, and I guess our x values, right? We'll have one last x value here. Because we're going to ask for our x values along from this x value here to this x value here. So these are all of our points of integration that we need to work our way across. So our first thing that we want to do is we want to find the equation for this plane that's cutting through. So this point M that's working its way across is going to come in at some xy value here, x comma y, and it's going to leave when it punctures the plane here. And that plane we need to solve for. So notice if we have any two vectors, they form a plane. And so these two vectors here are what we want to be able to talk about. We want to talk about, let's see, what happened to point C? Did I erase point C? All right, that's point B. And this was point C at 0, 1, 1. And so the vectors that form this plane is the vectors from OC, OA to OC. All right? And the cross product defines the normal to the plane. And so the plane that we're going to puncture through here would be the cross product from OA to OC. And let's see, so OA from origin to point C is 0, 1, 1. And from the origin to point A, forming these two vectors here, which also define the plane. So the cross product is going to be OA, which is 1, 1, 0, and OC, 0, 1, 1. And if we take our I components, we get I hat, 1 I hat, 0 j hats, and a positive k hat. Right, coming down, 1 I hat, 0 j hats, 1 k hat, and then in the negative direction, 0 k hats, 0 I hats, and 1 j hat. And so the vector we're looking at is I, negative j, positive k is the normal to the plane that we created here. And so that vector can be represented by 1, negative 1, 1. And if we want to think about the z value of what's happening here, then the equation for this plane is x minus y plus z equals 0. And from this point moving across to this point coming out, then z is equal to negative x plus y. So I think that's going to be our first term of integration. Z equals 0 when we come out of here, or come into the tetrahedron. Then when we exit the tetrahedron, z is going to equal negative x plus y. So we used our points of integration here. Now when we come across the plane this way, we can look at the shadow a couple different ways. Your book redraws the grid in x and y, but I can see here that this is a triangle in x and y, and this line here goes from 0 to 1, 1, where that's the line y equals x. So this comes in with y equals x. All right, when it punctures here, it punctures y equals x. So y equals x, and it leaves at y equals 1. So following the lines that we create, we come in at y equals x, and we leave at y equals 1. And then the last term of integration for the x values, well, x starts at 0 and ends at 1. So this will be 0 to 1. And we said we wanted to find the volume of this, so we're going to integrate dz, dy, dx as we integrate across each term, since there's no function that's being taken over these. So we'll do our first integration. We'll do dz to the constant 1. So that's going to be z evaluated from 0 to negative x plus y. And since the 0 is going to fall away in the fundamental theorem, this turns to a double integral now. And I'll write it in this order, y minus x. I'll flip right. dy dx. So now we'll integrate within terms of y. So that's y squared over 2 minus xy evaluated from x to 1. So we're going to get, putting the 1 through, 1/2 minus x minus see if I get my signs in correctly. So minus x squared over 2 plus x squared dx. All right. The 1 goes in here, that's 1/2. The 1 goes in here, that's negative x. Now we're going to subtract x squared over 2, and then we're going to subtract x times x, or x squared. So this is going to simplify. To 1/2 minus x plus x squared over 2 dx, which is going to be 1/2 x minus 1/2 x squared plus 1/6 x cubed evaluated from 0 to 1. And so the 1s are going to give me 1/2 minus 1/2 plus 1/6, or 1/6. And so we have the volume of our tetrahedra.